started volume yet. We'll just work on the surface area one. Okay, so we need to get an example in for the pyramid, for the cone, and for the sphere. So what would be exciting? I don't know if we have a good pyramid anywhere. I guess we can just make something up. What would you guys like this to be?
4.
2? Okay, I heard 2 first. Now that I think about it, 4 would have been more exciting. Okay, do you want me to give you the actual height, or you want me to give you a slant height? Okay, so if I give you a slant height, you want to make that a 4? Okay, and mathematically, I don't know that works out. Okay, let's just go for that. So I'm just going to focus on finding the total surface area of it. And so for our formula for our pyramids is 1/2 capital PL plus cursive B, or capital B. So this is a formula for all pyramids. So we saw quite a few pyramids yesterday in our work. Okay, capital P means what again? Perimeter of the base. And like I said yesterday, we're going to assume that all these bases are regular unless otherwise stated, which means all the sides are the same length. So what would the perimeter be if this is 2, 2, 2, 2? 8. Okay, and then I gave you the slant height in the picture, and the slant height is 4. And then capital B stands for what again?
Area of the base.
Area of the base. And what would the area of the base be? 4. 2 times 2, which is 4. Okay. Take a second, work that out. Tell me what you get. You get 20. And I'll just stick with my meters, and it would be meters squared. Now, of course, if you weren't given the slant height, if you were given the actual height, you'd have to do Pythagorean theorem or something else to figure out the slant height. Okay. The cone. Let's do a diameter instead of a radius. What do you want the diameter to be? 20. Okay. Diameter would be 20. You want me to give you an actual height this time?
Yes.
Or a slant height?
No, actual height.
Yeah, let's do an actual height. That would be exciting.
Do we need a one?
That would be a what? What do you want that to be?
7, 5.
Okay, I heard 7, so we'll stick with 7. Okay, so let's look at that piece of information. And yesterday and the day before, you guys kind of liked that last formula, so we'll just go for that last one there. So total area, let's have that be pi r, and then in parentheses, L plus r. And that's a cursive L for slant height. Okay, and then my second step is for the plugging in of my numbers. So I'm going to recopy pi. What's the radius?
10.
The radius is 10. 20 is all the way across. That's your diameter. So your radius is half that. Your radius is 10. Do I have the slant height in this picture? No. So I need to do what?
Pythagorean theorem.
Pythagorean theorem. Autumn, can you get off your phone and tell me how I could do this, please?
The problem?
Yep. The part of the problem that I'm currently on. I'm in search of this cursive L, the slant height. How could I figure out that slant height right there? And what would it look like?
30, 60, 90, the top would be 30.
Well, I don't know that. I don't have enough information to do that. But if it's Pythagorean theorem, like you said, what would the a squared, the b squared, and the c squared be? What squared plus what squared is what squared?
Would it be the 10 plus, okay, so it'd be 10 plus 7 equals?
The only thing is you just have to square it. So it'd be 7 squared plus the 10 squared equals the x squared. Because your Pythagorean theorem is a squared plus b squared is c squared. So it's 7 squared plus 10 squared is your c squared or your x squared. Okay, let's work that out and round to the nearest tenth. And what do you guys get when you round that to the nearest tenth? 12.2 for the slant height though? 12.2? Okay, so we get about 12.2 for the slant height. So I'm going to come over here and I'm going to put that into the cursive L. And then it wants me to add the radius. And what's the radius again? The radius is 10. Okay, so let's just go ahead and leave this in terms of pi. And if I leave this in terms of pi, we get what pi?
222 pi.
Beautiful, 222 pi. And I'll just stick with my meters. And once again, it's meters squared because area is always in square units.
Down.
So, in the pyramid, I gave you the slant height, so we didn't have to do anything fancy. We just plugged it in. And this one, I didn't give you the slant height, so we did Pythagorean theorem in order to figure out the slant height. Okay, and then this last guy, we have a sphere. And I'll go ahead and I'll just give you the radius. What do you want the radius to be? 5? Okay,
70.
there it is. I like 5 better than 70. This one, we only have the one formula, 4 pi r squared. And what did we say the radius was? 5, so it'd be 4 pi times 5 squared. Okay, go ahead and work that out and leave that in terms of pi.
100 pi meters squared.
Yep, 100 pi meters squared. Doot, 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 doot. Boop, 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 boop. Okay, so now we have an example for surface area, and then next week we're going to start volume, and so we'll get in some examples for volumes. So we'll have a quiz on Monday. For right now, we're going to do more surface area, but you can see our shapes are a little more exciting because they're composite shapes. They're made up of more than just one shape. Okay, some of these I'm going to work all the way through with you, and some of them I'm just going to kind of get a game plan and see if you kind of know basically what you would do. And one thing about these problems is you could do them differently than I might suggest. So we'll just kind of talk about it. Now this one is actually a real life application, and it wants us to consider this to be a greenhouse. And it says that the surface of the greenhouse is covered with plastic or glass. And it says find the amount of plastic needed to cover the greenhouse shown. So if this was actually a greenhouse and I was going to cover it with plastic or glass, would I cover the entire thing?
Yeah, no.
What wouldn't I cover?
The door.
True.
The bottom of it.
But we don't even have a door in the picture, but true.
The bottom.
The bottom. You could have a glass door, though. You'd have like a piece of framing, though, that wouldn't be considered in there. But the bottom. Do you agree that we wouldn't cover the bottom with the plastic or the glass? Okay, so I won't do the bottom at all. Now, what do you see when you look at this? What shapes do you guys see?
Rectangles.
Rectangles?
Pentagon.
There is a pentagon.
And more rectangles. And a triangle.
Okay, so it kind of depends on how you think of this. You could work with this as a pentagon. It'd probably be easier if you split it into 2 triangles and worked with these 2 triangles and then maybe the rectangles instead of thinking of this as a pentagon. Okay, so if I want to find the surface area, I do have these 2 triangles. So let's start with just that right there. So I'm going to find the surface area of my 2 triangles. And how do you find area of a triangle?
1/2 base times height.
1/2 base times height. Okay, because I have 2 triangles, then I'm going to take 2 times my base times my height divided by 2. Now technically those 2's will end up going away, but I'm just trying to show all my work here. I have 2 triangles, and you find area of a triangle by taking base times height divided by 2, and the reason I have this 2 out here is because there's 2 triangles. Okay, so I'm going to take this triangle and I'm going to blow it up a little bit up here, just so I have a little more space to work with. And let's look at what we know. This piece right here is 10, so that's this guy. This guy right here is 10. Do you know how long this piece is right here?
12.
That's a 12. So this whole base here is 12. My problem is I don't know the height of that triangle, so I need to work that out. So if I draw this in, do you know what this is right here? 6. and I need to know the height of that triangle. It's 8. This is a 6, 8, 10 triangle. But if I didn't know that, I could do Pythagorean theorem. Do you need to see me do Pythagorean theorem, or are you okay knowing it's a 6, 8, 10? You're good. Okay, so now I know everything I need to know. What's the base of my triangle? 12. What's the height of my triangle? 8. Okay, take a moment and work just that out. And this will give me the area of my 2 triangles.
No.
Yes. Whoever said that?
96.
96. So that's my 2 triangles. Okay, but I'm not done. So on top, how many rectangles do you see on top?
2.
There's 2 rectangles on top. So I need to find this rectangle on top, and then I'm going to find this other rectangle on top. So let's look to see if we know what its dimensions are. So hang on. Over here I'm going to find surface area of 2 top rectangles. So right now I'm going to try to find these 2 top rectangles that I colored in green. Okay, let's see if we can do this part in our head. How long is this one right here? 25. And what's this one right here? It is 10. So I have one rectangle that's 25 by 10. So I'm going to take 25 times 10. And then I'm going to add that to my other rectangle. And do you know what size the other rectangle is? It's the same. It's another 25 by 10 rectangle. And what do you get if you take 25 times 10?
250.
So 250 and another 250 makes 500. Okay, so that gives me the 2 top rectangles. Do you know how many rectangles are left?
3. Other
2.
5. 6.
There's 2.
You already told me I wasn't going to do the bottom, right? Now, would there be this rectangle right here?
Yes, it's 5.
No, there's not that rectangle. This is the roof right here. And so I'm not going to have this top rectangle. I will not have this top rectangle right here. I won't have this one, and I won't have the bottom because I'm not putting plastic or glass on the bottom. And I don't have this rectangle here because that's what the roof is sitting on top of. So I have how many rectangles left? 4. Now, we have a choice. We could do this 2 ways. I could either find the area of these 4 rectangles and add it to everything I've got so far, or I could use a formula. If you've just found these 4, is that lateral surface area or total?
Lateral.
I could use the lateral surface area formula, and that would give me these 4 and call that good, or I could find the 4 individually. What would you rather do? Would you rather use a formula, the lateral surface area formula to get these 4, or would you want to try that? Okay, so my other thing I need to find, and that's me finding these 4 rectangles right here. Those are the 4 I'm going to try to find. And I'm going to call that the lateral area of the rectangular prism. Okay, so I need to find my formula chart. And our formula for lateral area of a rectangular prism is capital PH. So capital PH. And it really doesn't matter what you call the base, but I'm going to have the bottom be the base. So if I want to find the perimeter of that base, I'd add what, and what?
25, 12, 12.
Okay, and what do you get if you add 25, 25, 12, and 12? What did you say? 74. So that's capital P. And then how tall does that prism stand? 8. And if you take 74 times 8? 592. Okay, so now what am I going to do with all my answers?
Add them all up.
I'm going to add them all up. So I'm going to take my 96, my 592, my 500, and I'm going to add them. Can someone tell me what you get if you add this? Okay, so our total surface area would be 1188, and this is feet, and it would be feet squared. So you kind of have to think about what you do have. Sometimes you don't have the entire shape. Like with that rectangular prism, I don't have the top of it because my roof's on top of there. And I don't have the bottom of it just simply because it's a greenhouse and I wasn't going to put anything down there. But this guy right here, I used the lateral area formula, but I could have found this rectangle, that back rectangle, and the side rectangle like separately and just added them in. Okay, I want to look at number 3. So this time we're not thinking of this as a real life example. We're just thinking of this as the shape you see in front of you. What do you guys see? There are 2 half circles, but do you know what this thing is on top? It's actually something, this whole thing on top. Half a cylinder. Okay, so I'm going to find the surface area of half a cylinder. And then what else do you have besides that half a cylinder? You have what's the thing on the bottom? What's it called, this thing on the bottom? I know so many of you are involved in your own little conversations, and that's so nice, but right now I'm trying to do this. I have a half a cylinder on top. What is this thing on the bottom? It's a rectangular prism. Now, would you have both bases? No. I have this rectangular prism that's on the bottom, and because it's not a greenhouse this time, I will have this bottom base. But will I have this top? No. I don't have the top because the half cylinder is on top of it. So I have a rectangular prism, but with only one base. So I'm going to add to it the surface area of my rectangular prism, but it only has one base. So I've got my surface area of my half cylinder, and I'm going to add that to the surface area of my rectangular prism, but it only has one base. Okay, so first I'm going to work on my cylinder. And I'm going to go to my formula chart to look at my cylinder's formula. And if I look at that, I do want this bottom one. But because I only have half a cylinder, what will I end up doing here?
Dividing it by dose.
Okay, so I'm going to go ahead and I'm going to write that down. I've got 2 pi r and then h plus r. But I will end up dividing this by 2 because it's just half of a cylinder. Okay, I want to go ahead and get the formula down for the rectangular prism. But the fact that there's only one base, I want to see what you guys think. Okay, so rectangular prism. This is the formula that we use. Because there's only one base, do you know how this formula would change?
Just plus B.
It'd be a just plus B. Does everybody understand that? I just want to make sure. Since the rectangular prism that we're talking about, we're not going to count the top because the cylinder is on the top of it. Then instead of 2B here, I'm only going to have a plus B. And that's just because I'm using one base. Are you okay with that? Does that make sense to everybody? The 2 there is because there's 2 bases to the rectangular prism, but I'm taking this top base off because I'm not counting it, and I'm not counting it because the cylinder's sitting on top of that. So I'm going to use the capital PH, but only one capital B. Okay, now let's see if we can actually plug in numbers. All right, let's start with the cylinder. Do you know what the radius of the cylinder is?
3.
The radius of the cylinder is 3, because all the way from here to here is 6. So if all that thing is 6, that's the diameter, the radius would be 3. So I'm going to put 3 in the R. And then how tall does the cylinder stand? 15. And then the radius, once again, is 3. And then I'm going to divide by 2. Okay, go ahead and give me an answer for that. Yeah, keep it in terms of pi. 54 pi?
For the very top, and then divided by 2, 27.
Are you sure? Because these 2's will end up going away, because 2 divided by 2 is 1. So that's 18 times 3. So it should be 54 pi. Okay, now let's work on the rectangular prism. I'm going to go ahead and call the base this bottom piece. So if I want to find the perimeter, I'd add 6, 15, 6, and 15. And what would that make?
42.
42. Okay, and then how tall is that prism? It's 15. No, it's not 15.
Oh.
It's 4. If the 15 is part of the base, then the 4 is how tall it is. Okay, and then capital B stands for the area of the base. And how do I find the area of the base? Length times width. 6 times 15, and 6 times 15 makes 90. Okay, so what do we get if we work just that part out? 258. Okay, give me a final answer, but no, there won't be pi in it. So put the 54 pi in your calculator plus the 258 and give me to the nearest tenth.
427.6.
Yeah, it should be 427.6. 427.6. And this is inches squared. Okay. What I want you to do for me,
No homework. No homework. It's a beautiful Friday in school.
I want you to try number 5. That's it.
Right now?
Well, you have like 4 minutes right now. So that's what I want you to do for me. And then we're going to practice more of this on Monday, as well as have our quiz on Monday. But this is the only one that I want you to do for me.
Total area.
The total surface area of what you see there. So there may be something that doesn't get counted, because it's kind of like the last couple of problems a little bit. So see if you can do it. This is a little bit harder, and then we can talk about that on Monday. Plus we'll have the quiz, and then we'll do some more of this on Monday. Yeah, I have algebra 1. But you can come in. I mean, that's not a problem.